Okay, in this video we're going to look at using Grasshopper to make a parametric folded plate tessellation. And what we're looking at here is one that was made in Rhino. And the problem with this is nothing's parametric. We can't control the width or the length of it. We can't control the angle of the fold. We can't control the amount of tessellations. But if we look at Grasshopper definition of the folded plate, we see that here. Let's just hide the Rhino geometry. Okay, in this definition we see that we can control the rotation angle of these folded plates, so we can flatten it out to a flat plane. We can control the width in the X direction and the length in the Y direction. We can control the number or the count of the array. So this can grow in the X direction and it can also grow in the Y direction. Okay, so let's get started on making this definition. So I'm just going to go ahead and open a new document here in Grasshopper, and the first thing we're going to make is a rectangle. So I'm just double clicking and starting to type in rectangle, and I'm going to need my X width and my Y length. So I'm going to create a number slider, and I'm going to double click on this number slider and I'm going to set it to integers. I'm going to set the range of this slider to 90, and I'm just using that because 90 degrees is the furthest our fold can be, so I'll have that range set up for use later on in the definition. And for now I'm going to set this to 10. I'm going to go ahead and rename this slider. I'm going to right click on the word slider, and this is going to be my width X, and I'll plug that into the X for the rectangle, and I'm going to copy and paste that, plug this into the Y, so you'll see we have a 10 by 10 rectangle drawn in the Rhino window. I'm going to rename that slider. This can be width Y, and I'm going to set it to 30. Okay, so what we have now is we have our first rectangle. So I'm just going to start labeling this definition. So this will be our first rectangle. Okay, so now I want to be able to rotate this rectangle about this axis on the far right. So I need to be able to grab that axis or isolate it. So I'm going to go ahead and explode this rectangle into a series of lines. So I'm going to use explode curve, and the rectangle is the curve that I want to explode. Okay, now my output, my S output has 4 lines coming out of it. So I need a list item to be able to isolate those curves. So I'm going to plug my list of lines into that list item. I need a number slider, and I'm going to change this number slider's range. I'm going to change it to 3. So I have 0, 1, 2, and 3. And I'll plug that in, and I'm going to go ahead and rename this. So this is going to be my axis of rotation. Okay, now if I click on the list item, you'll see that it's highlighting the line, and if I move this slider around, 2 is the top one, 1, that's the one I want to rotate. That's my axis of rotation, so I'm going to keep that there. So this explode curve, this was so we could isolate the axes for rotation. So I'm just going to, when I come back to this definition, I want to understand better why I use that. So isolate rotation axis. Okay, and I can make that smaller. Alright, so that's what this explode is doing. So next thing I need is I need a rotate. So I'm going to use a rotate axis. Okay. Now the geometry that I'm going to rotate is my original rectangle. So I'm going to plug that into the G for rotate axes. And I don't like when my wires cross behind components because it's hard to understand what I was doing, so I'm going to drop these down a little bit. Okay. So when I look at the inputs of the rotate axis, I have geometry, I have rotate axis, so I'm going to plug that in to the A. And then it's looking for, actually the second one is angle, rotation angle. So let me disconnect that one. Okay, the last one is the axis. So I'm going to plug that into the X. And now I need my rotation angle. So I'm going to grab one of these number sliders and I'm going to right click on it. So this is my rotation angle. And that's an important one. So I'm going to highlight this one in red. So I can do that by using the shortcut to group it, which is Control G. And I'm going to right click on that color that I put around it. And I'm going to go down to color and I'm going to make this all red. Okay. So this is my rotation angle. Now the A input for this rotate axis component, you see there it says rotation angle in radians. Well, my rotation angle for my number slider is in degrees, so I need a component that converts radians to degrees, or converts degrees to radians rather. So the input's degrees, the output's radians. So I'll plug that into degrees, and I'm going to plug this radians into my angle, and you see that rotating from 0 to 30. Well, I want that to rotate in the other direction. I want this flap to move down below the XY plane. So I need a negative number slider, or rather a negative component that changes that to be negative. So I can double click, start to type in negative, and I'm going to slip this in between here. Okay, so now I have this rotating correctly, and I'm just going to set this to 30 degrees to begin with. Okay, so this is my setup for my first rectangle. This is everything I need here. So I'm going to select it all, and I'm going to Control G to group it. I'm going to select this background color, and I'm going to right click on it and go over to color, and I'm just going to change its color. Okay, so now I need my second rectangle. So in Rhino, if I just show all my geometry, okay, so we have this first folded plate on the left. Now I need this right side folded plate. So we're going to go ahead and make that. Okay, so my second rectangle. So I'm just going to copy and paste this text, pull it down here, and this is going to be the second rectangle. Okay, so what I can do is this last rotation axis component, that is our folded plate. I can mirror that to the other side. Now what I'm going to need is I'm going to need a plane to mirror about. And I'm going to host that plane to this vertice, this lower right vertice. So I have to isolate that vertice. So I can do that with this explode component, okay, because that has a list of vertices coming out of it. So what I'm going to do is I'm going to create another list item and number slider setup. So I'm going to take these using my shift key, selecting them, Control C, Control V. Okay, I'm going to rename this. This is going to be point for plane. Okay, now the list that I need plugged in here is not the list of line segments, which is what's currently there. I need the list of points. So I can grab that from this explode component, from the V output is the list of points. So I'm going to go ahead and plug that in to the list. Okay, and now you see that list item number 1 is that lower right hand point. If I just move that number slider, you'll see 0 is the lower left, 1 is the lower right, 2 is the upper right, 3 is the upper left. So I'm going to set that back to 1. And now I can create a plane about that point. And that should be a vertical plane. So it's going to be a YZ plane because it's along the Y axis. So I'm going to choose YZ. It's looking for an origin for its input, and that's going to be the point. Okay, now you see a plane in Rhino that I can mirror about. Okay, so the component I need is mirror, and I'm going to go ahead and plug that into the G input. Actually, the G input should be the geometry. So I'm going to plug my geometry in there, and I'm going to plug my plane into P, and that's going to mirror to the other side. And you'll see I can flatten this out at 0 or make a full fold at 90 degrees. So now we have our folding working, and I'm going to go ahead and select all these components that make up the second rectangle. Control G to group it. Right click on it and change its color. Let's do red and green, make yellow. Okay. The next thing we need to do is set up our tessellation or our arrays in the X and the Y direction. So let's go ahead and start with the Y direction because that's a little easier. So I'm going to bring down a scribble here, and this is going to be my placeholder. So this is X direction array. So I'll leave that there and copy and paste that. And we need a Y direction. And we'll start with the Y direction because that's a bit more straightforward. Okay, to make an array, I need a series of components. I need a move, which in Grasshopper will act as my copy, and I need a direction vector to move along. In this case, we're working on the Y direction. So I'll double click and bring out my Y. And then we need a series, which will give us a count for the array and the distance between each item. So I'll double click and start to type in series, and I'll plug that into my Y. Okay, so the count can be parametric, so I just need a number slider for that count. Copy and paste one of these. Okay, so this will be our Y count. and that's going to go into the C for series. And the distance between each one of these elements in the array, I can use the n input for that. And what I need is basically the y width of this. So this 30 here, I can plug that into the end of the series. Okay, so that's set up. Now to actually see that, I need to plug the geometry that I want to array. And that's going to come from both of these. This component is the left rectangle, or the first rectangle, and this is the right rectangle, or the second. And I'm going to plug both of those in using the shift key, plug those into the move. Now there's two lists being plugged in, and you see this array, let's lower this count from 30. It's only taking one of the lists. So I just need to right click on the move component and change it to cross-reference. So it uses both lists. And there you see that array working properly. So that was pretty easy. And because we use this with y for our distance between each item in the array, as this changes, the array updates. So it's fully parametric. Now, for the x direction, I have to solve for a distance. I can't use this width, because this width is the width of the rectangle before it is folded, and it's only the left side of the rectangle. I need to solve a distance between this point that my cursor is on and this point. So to do that, I need to access these points to begin with. So let's walk through the steps of doing that. Okay, I'm going to group my y direction array together. Change its color. Okay, so we're gonna set up a series of components that solves for the x distance. So I'm just going to label that. Okay, so I'm going to need a couple of explode curves so I can access my points. And the first curve that I'm going to explode is the left rectangle, so I'm going to go ahead and plug that in. And I now have access to this point, so I need to get access to this point on the lower right. I'm going to copy and paste my component. I'm going to plug in this mirror, because that's the right folded plate. Plug that into curve, and now I have this point. Okay, so I need to now isolate those points with a list item and a number slider. So I'll bring out my list item. It's my list of points which come out of this V from the explode, and I need a number slider. Copy and paste one of these, zoom in a little bit, and this is point 1. Okay, and that, if I move my number slider to 0, you see I have access to that point. I'm going to copy and paste this number slider and list item, and my list now needs to come from this list of points, so I'll plug that in. Okay, click on the list item, and there you go, I have that point. So now it's the distance between this point and that point, and I can use my distance component, plug this into A and this into B. And if I put my cursor over the D output of distance, you'll see I have a value there, 17.3 something. So now I have the distance between those points, and it's fully parametric. So this can be my distance for my x direction of my array. So I can group all of this together. Change its color. Okay, so now I just need to set up my x direction array very similar to my y direction. So I need a move for the array. I need a direction, which is the x. The geometry that I'm going to array can come out of my y. Okay, if I zoom out here. So I can take all of this y array geometry and array it along the x-axis. So I'm going to plug that in. Okay. And I need a series. Okay. Make sure this move is using cross-reference. Okay, so now I'll take this number slider down here and copy and paste it. This is now going to be my x count. Okay, so now I need the distance between each of these in the x, and that's going to come from my solve for x distance. So I'm going to plug that in to the n, and you see that's working nicely. So I can group all of this together. Okay, and just to see this better, we're going to add one last component which turns everything into surfaces. So I'm going to use planar SRF, and really I just need to plug my last component in because that's the entire x and y array. Plug that into planar, label that. So this is these are my surfaces. Okay, so now we have a fully parametric definition for folding these plates from flat to 90 degrees. I can control their width in the x direction and the width in the y direction, as well as the count in both of those directions, so x and y. Okay, and here is our full definition.